Hello everyone, we are Group 6 and we are going to be discussing data mining. But first, what is data mining? So, by definition, data mining is the process of searching or analyzing a large batch of raw data and then identifying patterns and useful information. To further break down the meaning of data mining, we will be using an analogy. Imagine yourselves with a treasure chest in front of you, brimming with treasure. However, not all of it is useful to you. Therefore, you begin mining, picking out the items useful for you and leaving the irrelevant ones perhaps for future use. Data mining is like sorting through a treasure chest of data and then finding the important bits. This is how data mining becomes very useful due to how data is continuously growing. Eventually, people will have stacks upon stacks of data, and having an algorithm that can quickly find what you need is perfect. That's not the only use for data mining, as data mining also helps in identifying the patterns. These identified patterns can then be used to predict future trend behaviors, making it very useful for various fields.
As mentioned earlier, data mining is used to sort out large datasets in order to find valuable information. There are several ways and techniques data mining uses in order to convert those data into a useful output. The three popular data mining techniques are association rules, classification, and clustering. Firstly is the association rules technique. This technique simply searches for relationships, patterns, or associations between variables. Association rules are an if-then statements that help to show the probability of relationship between data items within large datasets in various types of databases. This is a number of applications and is commonly used to help discover sales correlation in transactional data and understand consumer behavior. So, for example, imagine that we are an admin here at DLSU, and our job is to analyze where students spend their money around the campus, such as in Pericos, Potato Corner, Coffee Bean, National Bookstore, Power Mac, and etc. And we have a dataset containing information about student transactions, including the items purchased, where they bought it, and the age of each student. Using association rules, we can search for relationship between students' ages and their spending habits on campus. This can help us identify patterns and understand how students' age demographics influence their purchasing behavior. For instance, after analyzing the data, we might discover the following association rule. Firstly, if a student is between the ages of 17 and 20, then they are more likely to spend money on snacks and potato corner. And if the student is between the ages of 21 and 23, then they are more likely to spend money on coffee and pastries and coffee bean. Second technique is classification. Classification technique uses predefined classes to assign to objects. The classification algorithm is a supervised learning technique that is used to identify the category of new observations on the basis of training data. In classification, a program learns from the given dataset or observations and then classifies new observation into a number of classes or groups. Let's create an example that classifies College of Business students. Suppose that we are tasked with predicting whether college students belong to the College of Business or COB or not, based on the data such as their majors, subjects taken, and organizations they are in. With the use of the classification technique, we will be able to learn patterns and relationships between the input features or the majors, subjects, and organizations and the target variable COB or not COB. And once trained, the model can predict whether college students belong to the College of Business, which is COB, or not based on their characteristics. Overall, classification techniques help us learn patterns and relationships between input features and a target variable, allowing them to make predictions for new instances based on their characteristics. And lastly is the clustering technique. This is used to group similar data points together based on their features and characteristics. It is an unsupervised learning method that helps to identify patterns in large datasets and segment them into smaller groups or subsets. A simple example of clustering would be the ID numbers here in the LSU. Suppose that we are tasked with clustering college students based on their student ID numbers to identify patterns or anomalies. In this dataset, we have information on college students including their student ID numbers. Our goal is to group similar students together into clusters based solely on their student ID numbers, regardless of their college and majors. To achieve this goal, clustering technique comes into place and helps us analyze the similarity of student ID numbers and group them into clusters.
Let us now move on to the 5 steps of data mining. The first step is identification. This is where we define the problem we want to solve or the goal we want to achieve through data mining. This is where we understand the domain, the data available, and the questions we want to answer, such as databases and operational systems. The second step is the data collection and exploration. This is where we gather the relevant data from various sources. This could include databases, data warehouses, spreadsheets, APIs, or even scraping data from the web. The third step is data preparation and transformation. First, we pre-process the data to handle missing values, outliers, inconsistencies, and noise. This step is crucial for ensuring the quality and reliability of the data for analysis. Second, we combine data from multiple sources if necessary. This involves resolving any inconsistencies or conflicts between different datasets and creating a unified dataset for analysis. Third is where we convert the raw data into a suitable format for analysis. This may involve normalization, aggregation, discretization, or other transformation to make the data suitable for the chosen data mining techniques. The fourth step is modeling. First, we select the appropriate data mining techniques based on the problem at hand and the characteristics of the data. Common techniques include classification, regression, clustering, association rule mining, anomaly detection, and text mining. Next, we apply the chosen techniques to the prepared dataset to uncover patterns, relationships, and insights. This step involves running algorithms or models on the data and interpreting the results. Last is where we analyze the results of the data mining process to extract meaningful insights and actionable conclusions. This is where we evaluate the quality and significance of the discovered patterns or models using appropriate metrics and validation methods. The last step of data mining is deployment. This is where we deploy the results of data mining into practical use. This could involve integrating the insights into decision-making processes, building predictive models into operational systems, or implementing recommendations for business improvement.
In today's age of technology and information, data mining is used in various industries, sectors, and departments to help businesses make informed decisions in their strategies. A company can leverage data mining to determine its ideal product lineup and enhance marketing effectiveness by strategically placing ads, targeting specific demographics, and aligning campaigns. For instance, it can be applied to see patterns in online shopping behaviors, allowing marketers to tailor their advertising content and pricing strategies. In the healthcare sector, data mining plays a key role in analyzing medical records and treatments. It allows patterns to be identified, including improvement of diagnosis and treatment strategies. For example, it can be used to anticipate the likelihood of certain health conditions based on the patient's lifestyle factors and demographics. In the retail industry, data mining helps optimize inventory and supply chain management. In particular, it can help anticipate which product will be in high demand on a certain date or period, improving overall efficiency in stock and customer satisfaction. Moreover, in tracking purchasing habits, data mining enables the use of joint purchasing patterns to recognize product associations and then decide how they are placed or displayed on shelves or aisles.
So before we start coding, we must first do our initial setup. First, download the CSV file provided in the Google Drive and save the file into a folder, and make sure to place the folder somewhere you may easily find. The CSV file is the dataset that we will be using for our demonstration as well as for the exercise. Next, create a new Python file in VS Code and immediately click on Save As, and make sure to save the file in the folder where the CSV file is located. This step is highly recommended because doing so will allow Python to easily find and use the dataset for data mining. Next, go to the top left corner of VS Code and click on File. Then click on Open Folder and locate the folder where the Python file and the CSV file are located, so that VS Code can easily locate both files so that they may work together without any problem. Now, we perform a pip install of the pandas library in Python by typing the code python3-m pip install pandas in the terminal, and make sure to type pandas with an S, otherwise it will not do anything. And once finished, we can start coding. For the first part, we should import pandas in our Python file by typing import pandas as pd. Then, for us to use the data found in the CSV file, we should assign a variable to the dataset file. Now, let's say we want the variable to be named data. So, we type in the code data is assigned to pd.read underscore CSV open and close parentheses student underscore spending.csv. And as we can see, the item we type in the parentheses is the name of the CSV file you downloaded. Make sure to type exactly the name of the CSV file, otherwise Python will not recognize it. This line of code allows us to use the pandas library to tap into the dataset file and base our outputs on the data found in the file.
For the first part of this demonstration of the functions, we will first ask Python to show us some general information about the data we will be using from our CSV file. This is important because before you start mining for specific data, you should know at the very least what type of data you are dealing with, and you should also know what could be the types of data that you can try to mine for. To do this, let's first create a new variable named info and assign it to data.info followed by parentheses at the end. Then we print and then run. In our code, data will be the dataset that we are using, and info is the function we will use to get a concise summary of the dataset's contents. And as you can see in the terminal, our output shows the index of the columns as well as the names of each column, and we can also see the different data types per column. In our case, we will only be using integers and objects, or also known as strings, but in other datasets you may also find floats and boolean values. Lastly, we can also see the number of non-null entries for each column, which are 50 entries for each column in this example. Also, just a little side note, I place empty print functions after each example just so that there would be a space in between each output so that it would not look too crowded. Next, let's say we now want to find the number of entries in each specific age group. All we have to do is first create another variable, we can name it ages, and assign it to data followed by square brackets and the name of the column we are going to use, which is the age column from our dataset, followed by the function value underscore counts with parentheses at the end. Then we print our variable, then we click run. As mentioned earlier, age is the name of the column found in the CSV file, and we are simply trying to narrow down the type of data we want to look into. And value underscore counts allows us to find the count of how many times a specific value occurs in the age column. And as you see in our output, the age group that's on top is the one that has the most number of occurrences, followed by the rest of the groups in descending order. For the last example, let's try to make our output use two columns in our dataset, and let's say we want to know the average income per age group. To do that, we would need to make use of another function called the group by function. We create another variable, which we can name age underscore income, then we assign it to data.groupby followed by parentheses, then we use the age column again, and then we enter the second column that we want to use, which is the monthly underscore income column found in our CSV file. Then we add .mean followed by parentheses at the end, since we're trying to look for the average monthly income. Then we print age underscore income, then run. For this example, the group by function allows us to sort through each of the data found in the age column and turn them into groups. The monthly underscore income.mean portion allows us to get the average monthly income per age group. This portion sorts the data by age and then calculates the average within each age group. And now, based on our output, we have the average monthly income per age group.